Like the individual exercises only has like 7 of them. So
which is nice.
problems will be hard, but whatever.
Yeah. A
Okay.
few of these were crazy, but
Yeah, I finished all of them except part 2 and 9, and then part 7.
say that again.
I finished all of them except part C on number 9, and then number
Okay.
7 I started and I didn't want to do. All right. So for the first one, I said that the object with a larger mass will have more momentum because the equation is k e equals 1/2 mv squared.
That is that is correct.
Okay.
Yeah, that's what I got.
Okay. What'd you put for 2?
So for two, for part A, I used the equation P equals mv, rearranged it so I could find m,
Yeah. So I have
and
for me. Yeah, that's what I did.
yeah.
Sorry, keep going. I won't interrupt you.
So no, it's okay. So I got 1.2 by 10 to the 8th.
That's what I have. And then for part B, I multiplied 1,100 by the 1,200. And then I got 1.32 times 10 to the 6th. And then I divided the original momentum by that momentum, and I got that the ship is 1,212 times larger than the artillery shell.
That's what I got.
Okay.
Nice. At least it's pretty straightforward this time, or
Yeah.
most of it.
All right. So for 3, for A, I did the M1 V1 plus M2 V2 equals M1 V1 equals M2 V2, but they're prime ones, so they're the separate object. And so for A, I did 1 multiplied by 0 plus 0.02 multiplied by 0 equals 1V plus 0.02 multiplied by 600, which gave me negative 12 meters per second.
And that's what I got as well.
Okay, and how'd you do B?
So for B, so I wrote as initial and final,
Mm-hmm.
but so I used the V1 squared equals V plus 2AD.
Okay, that's what I did too.
Rearranged it to find for A, so we could find force. And for A, I got negative 360 meters per second squared.
Okay, that's what I thought. And then I used the F equals MA.
Uh-huh.
So then it was just the negative 360 multiplied by 1, which is negative
And
3.
that's what I got too.
Okay. And then for C, I
And
have to calculate for the force exerted on the gun if the bullet has its velocity at 10 meters per second or milliseconds. I have F equals mass times change in velocity over change in time. So then I have 0.02 multiplied by 600, and then I divided that by 10 multiplied by 10 to the negative 3 divided by 1, so I could get the milliseconds. And that gave me negative 1.2 times 10 to the, I think it's 2, but I can't really tell what I wrote.
it's 2. That's what I have as well.
All right, so what'd you get for number 4?
So number 4, so based off of the equation m1 times v1 equals negative m2 v2. So there's a negative in there. So if V1 has the opposite direction of V2 so that the momentum is canceled out.
Okay,
So
that if
it
two objects
can.
are moving in opposite directions, the momentums will zero each other out. You just have
Right.
actual explanation with your equation. All right.
Yeah.
For 5, it says, must the total energy of a system be conserved when the momentum is conserved? And I said no, because in inelastic equations, we know that they don't conserve kinetic energy, but we do conserve momentum, and that kinetic energy is converted to another form of energy. So just because momentum is conserved doesn't mean energy is.
That's what I got too. Or very similar to it anyway.
All right. For 6, I used the equation m1v1 plus m2v2 equals m1 plus m2 multiplied by velocity. So then
Okay.
I set that up to be 0.2 multiplied by 0.75 plus 0.35 multiplied by 0 equals 0.2 plus 0.350 multiplied by v. And then I got from that, like doing the algebra, I got 0.150 kilograms meters per second. So kg multiplied by meters per second.
Okay.
And then to get the final velocity, I divided that by, where is it? The two masses added together. So the 0.2 plus 0.35, which gave me 0.55. And that gave me 0.273 meters per second.
That's what I have. Same
Okay.
manner.
Okay, so you're going to have to show me how you did 10, because I got to the part where I used the equation m1v1 plus m2v2 equals m1 prime v1 prime plus m2 prime v2 prime.
For which one?
7.
7. Okay, this one was simple but also a little confusing at first.
Okay. Yeah, because I did it and then I was like, well, there's 2 unknowns, and then I knew I could solve it and then substitute it, but
So this is what was strange for me
okay.
is so when I was trying to look up examples of it, like
Mhm.
to understand what equation to use,
Yeah.
they were using all these crazy things, and then I remembered the lab. And the lab, to find the finals of the first and second object, it gave you 2 equations
Yeah, to find like
for
V2.
for an elastic collision where the items go have the same direction as they go forward and back.
Oh, okay. I remember those. And those equations worked?
Yeah.
Mm.
So the example had the same question, but they had a different one for V2, but it was close. So what they had was a 0.144, and with the equation I got a 0.149 for V2.
Oh,
The V1 basically was the same with a negative 34.85 for the puck.
all right. That makes sense to me. I didn't
Yeah.
even think about, I don't know. I guess I have them right here. I didn't even think about those equations for some reason. I was stuck on the M1 V1 and plus M2 V2.
It's all good.
So did you
I was stuck on all of that, and then I was like, wait, it's right here.
like, oh, this is easier than it should be? That's how I feel like all of it is. When I finally figure them out in Maple TA, I'm like, that should have taken 20 seconds, and it took me 30 minutes at least. Every time. All right.
Yeah.
4, 8. To
Okay.
calculate the velocities of them. So I
Yeah.
set M1 V1 plus M2 V2 equal to 0.
Okay.
I have the 6.68 times 10 to the 27th multiplied by V1 plus 3.92 times 10 to the negative 25th V2 equals 0. And so then I subtracted the I'm trying to use my brain right now.
Okay.
So I subtracted the V2 side or the V1 side, and then I divided by the V2 number, or actually the opposite way around. Either way, it gave me V1 equals negative 5.8.7 multiplied by V2. And then I use the equation E equals 1/2 M1 V1 squared plus M2 V2 squared. And then I used the total energy I used. Where is it? That was the 8.8 times 10 to the negative 13.
Do you have an 8.8 or an 8.4?
8.4. For some reason.
Okay.
Okay, 8.4. And then I multiplied that by the 1/2. Yeah, the 1/2, the 6.68 times 10 to the negative 27, multiplied by 58.7, negative 58.7. Except I also didn't write 0.7, so I think I did that whole math wrong.
Okay. And then you also distributed the other part, right?
Yeah, then the plus 1/2, 3.92. But I think all my math is wrong because I didn't. First of all,
You
I
just
probably
forgot
got 8.4 wrong, and then I forgot to put the period in the 58.7, so it was 587. So, what did
Well,
you?
before you correct, let's see if it ties in with what I have, because even if something could be slightly off, you might just be like a decimal point off, not a number, just position.
What did you get for that for the first V1?
So V1, oh wow, I got negative 1.57 times 10 to the 7th meters per second for helium.
Yeah, I got negative 1.71, so I did something wrong.
Okay.
Okay, so then
And then,
the answers did change it a lot.
okay, never mind. And then for uranium, I got 2.68 times 10 to the 5th meters per second.
Okay. I think I did all of B right. So B was just the KE equals 1/2 MV squared, right? So I did 1
Right.
multiplied by the 3.92 times 10 to the negative 25th, multiplied by, oh, you know what? No, I got it wrong because I
Oh, the
used.
numbers. Ay. Well, at least you know the process. So,
That's true. Just
yeah.
please. All right. So what did you get for those kinetic energies?
So for uranium, it is 1.40 times 10 to the negative 14 joules.
Okay.
And then helium is 8.23 times 10 to the negative 13 joules.
All right. I mean, that makes sense. I know how to use the equation. I just have to rework it. All right. And then for 9, to get A, give me just 1 second. Let me go find out. I have another sheet somewhere where I worked it out initially.
It's all good. They were pretty big this time, these last couple.
I know. They're the worst. Okay. So for A, I multiplied the 5.5 by 9.
Okay.
And then I set that equal to the 0.85 kilogram bowling pin multiplied by 15 multiplied by cosine of 85 degrees. And then to that I added 5.5 multiplied by velocity cosine theta. And so then I just combine my cosine theta since they're both unknowns. And then I set it equal to the rest of the equation. So I ended up getting 8.79 meters per second squared. So I ended up having 5.5 times 9 minus 0.85 multiplied by 15 multiplied by the sine of 85. And then I divided that whole thing by 5.5 to get the 8.79 meters per second squared. And then I plugged that back in with sine, the same original equation, except that using v cosine theta, I used v sine theta. So I could solve for v sine theta, which I got 2.31.
Okay.
And then I set, because tan is sine over cosine, I divided them by each other, and then I took the inverse tangent to get 14.7 degrees.
Okay. And then did you what was it? Because what I found is after you find the 14.7, you do a v cosine of 14.7 equals the 8.8 roughly to find.
I got 9.1 using that, doing it that way. Is that what you got?
That's what I got.
Yeah. All right, and then for B, is the collision elastic? I said no because the energy isn't preserved.
Hello?
C, can you hear me?
Yeah, now I can.
So for B, I said that energy isn't preserved because there's a change in velocity. And then the equation for energy is 1/2 mass times acceleration, velocity squared. And we know that the mass is going to stay the same. So that means the velocity would have to change. And then for C, I didn't know how to answer it.
So this one I actually had to look up to see someone's example for C.
Mm-hmm.
And what they said was the spin would allow the, so if you put a spin on it,
Mm-hmm.
it can convert to linear kinetic energy because as it spins and it's going forward, that means when it hits that straight point,
Yeah.
it has more force.
Okay.
And then if you get it right, it can grab onto a pin and make itself go faster.
Okay, that makes sense.
Yeah, but has to be exact. But
Yeah, that's like if you're really lucky, but don't count on it.
if someone got that good, I'd forget about getting for the perfect score.
Yeah, I'd be like, you know what, you went up, cool. I just won't play with you.
Yeah.
All right. So since you knew how to do 7 through 9 better, do you want to send me a picture of your second page and I can turn in the first page?
Yeah. I can
Okay.
send you a picture of the second page.
Perfect. Let's do that. And then good luck with your test this week.